Good day, everyone. This is Mom Janine. So we are on the second week of our modular distance learning. Before we move on with our next topic, I would like to remind you that you have to first answer your diagnostic test. For online or blended learning, you have to use the the Google form to answer the diagnostic test. And while for the modular distance learning, you have to use the zip grade answer sheet that we have provided. Shade your answers on that answer sheet. Do not use any other paper for your answer. Okay? Now, if you're ready, then we're going to start our topic for this week. We have characterizing and describing the roots of quadratic equation. So let's have first a quick recap of what we have discussed last week. So this is the standard form of quadratic equation. It's ax squared plus bx plus c is equal to 0. So the key points here is you have to identify the numerical coefficients for each terms, a, b, and c. Okay, so first example, I have x squared minus 7x plus 10 equal to 0. Of course, your a is equal to 1 from x squared. B is equal to negative 7 from negative 7x. And c is equal to 10 because that is your constant. Okay, now for the second example, 5x squared plus 2x is equal to 0. Of course, we are missing one term here, but that's okay for as long as you are not missing the quadratic term, which is ax squared. So we'll have a is equal to 5, b is equal to 2, and c is equal to 0. Since we are missing the constant term, your c value will be equal to 0. And I also have last example, x squared minus 9 is equal to 0. Again, we are missing one term, but that's okay for as long as we are not missing the quadratic term. Okay, so for this, we'll have a is equal to 1 from x squared. B is equal to 0 because we are missing the linear term. And c is equal to negative 9 because negative 9 here is your constant. Remember that you always your standard form should be always equal to 0 for you to identify the a, b, and c values. Okay, so now for getting the roots. So we also have discussed this last. Okay, for our first example, we'll have x squared minus 7x plus 10 equal to 0. So there are several ways to get the roots. First is you can use factoring. So you just have to think of the factors of 10. And that would be, it can be 1 times 10, 1 times negative 1 times negative 10. That's still equal to positive 10. 5 and 2. Negative 5 and negative 2 also gives you 10. But in this case, we have to think of those factors that will also give us, that if we add those two factors will give us negative 7. So that is, so mag-x tayong ganyan. So that would be negative 2 and negative 5. Right? Because negative 2 and negative 5 are factors of 10. And if you add these two factors, negative 7 and negative 2 and negative 5 will give you the middle term or the linear term, which is negative 7. And then equate that to 0. So therefore, we can equate this 2 with 0. X minus 2 equal to 0. Which gives us x is equal to positive 2. And while the second factor, which is x minus 5, is equal to 0, we are also going to equate that to 0. Therefore, x here is equal to 5. So those are your two factors, 5 and 2. All right. Let's move on with the next example. This is 5x squared plus 2x equal to 0. So for this, we can also do factoring because we are missing the constant term. There is something common between 5x squared and 2x, and that is x. Their common factor is x. So if we factor out x from 5x squared, we'll be left out with 5x. And then plus again, since we have factored out x, we can also extract that from 2x. We'll be left out with 2 equal to 0. So that would be the next step would be equating each factors to 0. So we'll have x is equal to 0 because x is the first factor, and the second factor is 5x plus 2. So that's 5x plus 2 also. Equal to 0. Okay. So this is your first factor. Again, x is equal to 0. So we have to simplify 5x plus 2 equal to 0 to get the next or the second root. So transpose positive 2, we'll have 5x equal to negative 2. Becomes negative because you have transposed it to the other side. Divide both sides by 5. We'll be able to cancel 5 from x. So we'll be left out with x is equal to negative 2 over 5. Therefore, the two factors of 5x squared plus 2x equal to 0 is 0 and negative 2 over 5. All right. And last example, x squared minus 9 is equal to 0. Siyempre, the method that we can use here is extracting the roots. We're going to square root both sides. But before we can do that, we have to transpose first negative 9 to the other side. We'll have x squared equals positive 9. Okay, and then get the square root of both sides. We'll be able to cancel out squared from x. We'll be left out with x. And square root of 9 is positive and negative 3. Or we'll have two factors. Positive 3, I'm sorry, there should be a negative 3 here. And negative 3. Okay, so that is getting your roots. So for learning task 1, you have to complete this table, give the values for A, B, and C, and then the roots. Let's have the last example. Suppose we'll have x squared minus 9 equal to 0. Kanina nakuha na natin that A value is 1, B value is 0, and C value is negative 9. Well, the two roots is positive 3 and negative 3. We have just been done with that. And we're left out with this. Paano natin ito sasagutan? So you're going to actually use this formula, b squared minus 4ac. You have to substitute the values of a, b, c to this formula to get what you're going to write in this blank or in this table. So substituting the values, b for 0, a for 1, and c for negative 9. So we'll have 0 squared equals, 0 squared minus 4 times 1 times negative 9. And then you can simplify that. 0 squared is still 0, and negative 4 times 1 times negative 9 gives us 36. So therefore, will be simplified with 36. And this 36 is what you're going to write here. 36 to complete the table. So that is learning task 1. Now, the expression b squared minus 4ac is actually a quadratic equation's discriminant. So that's what we call the discriminant. It determines the nature of the roots of a quadratic equation. If you substitute the values of a, b, and c to the discriminant formula, which is b squared minus 4ac, it's possible that you'll get 0. You can also get a positive number, and you can also get a negative number. So again, by substituting the values of a, b, c's, it's possible that you'll be able to compute the discriminant equal to 0. It can be positive number, it can be negative. Now, when your discriminant is 0, the nature of the roots or the two roots will be real and unequal. When it's positive, your nature of the roots will be real and unequal. And if it is negative, it will be not real and imaginary. Okay, now so much for that. Let's try it with an example. Okay, suppose we have x squared minus 7x plus 10 equal to 0. So the discriminant, again, the formula is b squared minus 4ac. A value is 1, b is negative 7, and c is equal to 10. You get that from here, just what we have discussed before. So substituting the values to your formula, we'll have negative 7 squared minus 4 times 1 times 10. Simplifying, that's negative 7 squared, so that's negative 7 times negative 7. That's why we have 49 here. And 4 times 1 times 10 gives you 40. So that's simply 49 minus 40 is equal to 9. Now, 9 here is actually a positive number. 9 here is a positive number. Therefore, the nature of the roots is real and unequal. So, kanina, we already have solved for the roots of this example, x squared minus 7x plus 10, and we got 5 and 2. Now, as you can see, this 5 and 2 are real numbers and they are unequal. And we have proven that from the discriminant. Because the discriminant is positive, therefore these two roots are unequal and they are also real numbers. Okay, let's try to have another example. X squared plus 6x plus 9 is equal to 0. So if we get the a, b, and c values, a is equal to 1, b is equal to 6, and c is equal to 9. Now, if you actually get the roots of this quadratic equation, you'll get negative 3 and negative 3. Why? Because this is a perfect square binomial. So that's x plus 3 squared equal to 0. Or that's x plus 3 and also another x plus 3. X plus 3 equal to 0. So equate these two factors to 0, we'll get x plus 3 equal to 0. Therefore, your x value is negative 3. Ayun siya. And then do it on the other factor that also gives you negative 3 because it's the same. It's perfect square binomial. Now for the discriminant, let's go back to the discriminant. It's b squared minus 4ac. Substitute the values of a, b, c to this discriminant formula. We'll get 6 squared minus 4 times 1 times 9. So that will be 36 times 36. Therefore, your discriminant is equal to 0. Now again, what happens if your discriminant is 0? Your nature of roots are real and equal. So as we can see, these two numbers, negative 3 and negative 3, are equal and they are also real. And that is proven by the discriminant, which is 0. Okay? Alright, so this is learning task 2. We have to complete the table, values of A, B, C's, discriminant, and roots. So suppose I have this example, 3x squared plus x plus 5 equal to 0. So the values of A, B, C's is 3, 1, and 5. So to answer the discriminant here, you have to use the formula b squared minus 4ac. So if we would like to just substitute these values, that would be, ayan, medyo mali lang ako dito. We'll just change this to 3 because A value is 3. So that is 1 squared minus 4 times 3 times 5. Now, continue solving that. We'll have 1 squared, that is equal to 1, minus 4 times 3 gives you 12 times 5 gives you 60. And then, continue the solution or compute for this. 1 minus 60 is actually negative 59. So this negative 59 is your discriminant, computed discriminant. So you're going to write it here, negative 59. And then what you're going to answer in the nature of roots will be based on the conditions that we have, just like before. So the nature of the roots could be real and unreal. It could be real and equal, not real or imaginary. So from our previous example, we computed it as negative 59. So what you're going to answer in the nature of the roots will be not real or imaginary. But if you have computed for a positive discriminant, you're going to write on the last column real and unreal. But if you computed 0, you're going to write on the last column as real and equal. Okay, so that is learning task 2. For learning task 3, letter A, characterize the roots of the following quadratic equation using the discriminant. You have to copy and answer these 5 items. Compute for the discriminant and give the nature of the roots, just like before. Hindi na lang siya naka-table. Write your complete solution, copy, and answer. Now, for this letter B table, here's how you're going to answer it. Write the values of A, B's, and C's, find the roots, and then these 2 columns are actually the sum of the roots and the product of the roots. Now, how are you going to answer that? We have here a computation of the sum of the roots, that's x sub 1 plus x sub 2, and the product of the roots, which is x sub 1 times x sub 2. Now, this is actually a computation of the simplified form if we add the 2 roots. So we just simply have, for the sum of the roots, we can use the formula. We can use the formula negative b over a. If we are trying to get the sum of the roots, which is x sub 1 plus x sub 2, you just have to use the formula negative b over a, substituting the values of a, b, and c again. If you're going to get the product of the roots, which is x sub 1 times x sub 2, that is actually simplified form as c over a. This is the formula that you are going to use, substituting the values of A, B, C's again. Simple as that. Let's have an example. I have x squared minus 7x plus 10 equal to 0. ABCs 1, negative 7, and 10. So we just have to remember we have already solved for the values of the roots of this equation, which is 5 and 2. Now let's get the sum of the roots. So using the formula, negative b over a, so that's negative quantity negative 7 because your b is negative 7. That's why you have substituted that. And then a here is from a, that is 1 here. So that's negative of negative 7 over 1, or we simplify that because this is negative times negative, it gives you positive. And then 7 over 1 gives you 7. So therefore, the sum of the roots of this equation will be equal to 7. Now, as you can see, x sub 1 is 5 and x sub 2 is 2. If we add that, 5 plus 2, it will give you 7. And that is the sum of the roots. While if we are going to find the product of the roots using the simplified formula of C over A, substituting the values, C is equal to 10. That's why we have 10 here. A is equal to 1. That's why we have 1 here. And 10 over 1 is simply equal to 10. Now, remember, this is the product of the roots. Our roots is 5 and 2. If we multiply 5 times 2, it gives you 10 also. So that is the sum and the product of the roots. This is what you're going to use to supply your answer on the last table in learning task 3. So this is learning task 3. You can use the formula that I have given to you a while ago to answer this part of learning task 3. Okay, we're almost done and down to our last learning task. We have learning task 4. This is actually a transfer of what you have learned from this module. For learning task 4, you have to solve the problem by applying the sum and product of the roots of quadratic equation. So this is your problem. I would like you to draw it, make an illustrative representation of this problem. It's just a simple rectangle. Write the perimeter and the area in your illustrative representation of your problem, and then give your answer by applying the sum and product of the roots. So that is module 2. I hope you have learned a lot from this video, and we'll be seeing your outputs by the end of the week. That would be all. If you have further questions, just text or call your teacher, Ma'am Janine or Ma'am Nanet Mojica. That would be all. Goodbye.